Last time we talked about central tendency, which is a single number, an average, that tries to describe the entire data set. Today we're going to talk about another number that tries to describe how spread out the data values are. And the first type that we can use is the range. And the range is just the difference between the largest and the smallest values in the set. Standard deviation takes a little bit of calculation, but what it does is it measures the average variation of the data entries from the mean. So it's really a comparison type of thing, comparing to the mean. And then the variance is just the square of the standard deviation, and we will show how to calculate that today too. Let's start by talking about these two sets of numbers because they have some similarities that we will see. First, the mean. So the mean is where we add up all, 7 numbers and divide by 7 then. So let's add those up. I've got 10 plus 10 plus 10 plus 5. I'm getting 35 is the total. Divided by 7, and our mean is 5. The median would be the middle number, and there actually is a middle number this time, so 5 again. Looks like the mode, we have 2 modes, both 4 and 6 are modes, and the range being the difference between the largest value and the smallest value. These range from 0 to 10. 10 minus 0 is 10. Let's look at the second data set. When I add up all those numbers, I've got the 10 plus 10 plus 10 plus 5 again. So I've got a total of 35 divided by 7 numbers makes the mean 5 again. The median, again, is 5. The mode, we don't have any of these that happen more than once, so we would just say no mode. And the range, again, highest is 10, lowest is 0. 10 minus 0, the range is 10. Now what I want you to notice is that these two data sets have the same mean, the same median, and the same range. This one has some modes, this one doesn't, but there's actually a difference between these data sets, right? And so what we're going to try to do is think about how these data sets are spread out. Did you notice that these are a little more compact around the mean than these values? They're a little more spread out from the mean. So we're going to see how that affects standard deviation. Here are the formulas of the day. They're so complicated. Of course, I would not want you to memorize these. I will always provide these formulas for you. The first thing to notice is that we have different formulas depending on if we have a sample or if we have the entire population. And the only difference there is that for the sample, we take n minus 1, and for the population, we take the entire number in the set. The other difference is the type of letters used. Remember that for samples, we tend to just use regular letters like S, S standing for standard deviation, and X bar standing for the mean, where in population, we use the Greek S. The Greek S is a sigma, a lowercase sigma. And so standard deviation for a population, we use sigma, and then we use that Greek M, the mu, for the mean. Since those formulas are so complicated, I like to just take it step by step. So you'll notice I'm going to be using this formula down here to try to calculate standard deviation. And you'll notice that inside this square root, there's a sigma with an x minus x bar squared. So what we need to do is we need to take each of these x values, subtract x bar, and x bar is the mean, right? And then square it, and then, do you remember what capital sigma meant? Add them all together. So let's try that. Do you remember what the mean was for this set of data? And we're going to be talking sample standard deviation. So I will say that the mean here was 5. When we added all those together, divided by 7, we got 5. And so for column 2 here, I'm going to take each x value and subtract the mean. So what those numbers tell us is basically just how far is each x value away from that average. Since 0 was below the average, that one came out negative. Since 10 was above the average, that one came out positive. Now we're about to square each of those values. So negative 5 squared. Negative 5 times negative 5 is 25. Negative 1 times negative 1. So if we square each value in column 2, basically that's just taking away all of those negative results, right? These numbers that were further away from the mean are now represented as much larger numbers. The ones that are closer to the mean stay pretty small. So that's just kind of giving us a calculation that shows how far our numbers are away from the mean, standard deviation. Now one more time, we see this sigma right here, right? Sigma means we're going to take all of those column 3 entries and add them together. So if we add all of those together, what would we get? 54? 25 plus 25, and all those ones are 54. That's the hardest part of the formula. So now we can figure this out. We've got a big square root. We've got the 54 that we just calculated. Then on the bottom we just do n minus 1. And in this case, n, how many numbers are there? 7 numbers. So n equals 7 minus 1. We've got the square root of 54 divided by 6, what's a 9? We would say that our sample standard deviation is 3. And you'll notice that the sample variance is just the square of that. Or in other words, it's just this thing without the square root on it, right? 3 squared is 9. And so those numbers are meant to describe how much the other data values are varying away from that mean value. I had talked about how these values seemed a little more spread out away from the mean. So we're going to see how the standard deviation and the variance differ when those numbers are more spread out. Remember again, the average for this set, the mean for this set was 5. So when I'm going from column 1 to column 2, I'm just going to be subtracting that mean. I'm going to be subtracting 5. Now going to column 3, I'll just be squaring each of those numbers. And I think already you can see that we have a larger total here, right? Because those numbers are more spread out than the first set, we should get a larger total right here. In this case, the total is 76. So when we go down to do our calculations, the sum of x minus x bar squared would be 76 divided by 7 values minus 1. And that gives us our s squared, our sample variance. Standard deviation is the exact same calculation, just with a square root over it. So that sum of the x minus x bar squareds and the 7 minus 1 on the bottom. Okay, so here's what we're seeing. This first data set that was not as spread out, those numbers were clustered more around the middle, that had a smaller standard deviation than these numbers that were more spread out. So again, standard deviation is a measure of how spread out the values are from the mean.